Hello everyone, welcome to another webinar from our Rocky in Action web series. I start to share my screen. Mara, could you please confirm that you can see my screen?
Yes, it is okay.
Great. So thank you everyone for attendance. My name is Leon White and I'm part of the Rock support team. Today we are going to make a short presentation about DEM and structure analysis coupling using Ansys Mechanical. I hope you enjoy. So whenever we have a piece of equipment interacting with particles, can be from conveying particles, sorting it, mixing, breaking, and so on, the geometry will undergo certain loads caused by the contact forces with the bulk material. So here in a quick example, we can see the bucket of excavator digging up in the ground, collecting the gravel, and we can be interested on how this load will affect the structure. We can use finite element analysis to solve the structure behavior, calculate the acting stresses and deformations due to this particle loading. For that, we can run a coupled simulation using both Rocky and Ansys Mechanical to solve static and transient scenarios, helping us accurately predict such interaction. Let's talk a little bit on how this coupling works. To run a coupled structure analysis, we need to have the geometry on the rock side with an STL representation with a fine and smooth triangle representation to correctly capture the pressure field. Rock will calculate throughout the simulation all the forces at the boundary, and then we'll export at a single or multiple times this pressure field to be imported into Ansys Mechanical. Here we can see a very simple static example of a pile of material. This pile of material will affect this plate, acting for creating a pressure field over it, and we can export this pressure field into Ansys Mechanical. This is a simple static one, so we just need to do this at a single time, a static one. But how about the transient loads? For transient analysis, Rocky will export a set of pressure fields for each output in the selected time range. Can be through all the simulation, a given interval, or just the last few seconds of simulation. And every single pressure field can be imported back into Ansys Mechanical. So here we can see a rotating run, the pressure field applied to this geometry, and again, importing this pressure field back into Ansys Mechanical. It's very common to have boundary motions in Rocky, and this behavior should be correctly captured inside Ansys Mechanical. To enable this behavior, Rocky will translate and or rotate this load back to the original position of the geometry so that this geometry remains static in Ansys Mechanical. So let's take a closer look on how this works. Here we have a simplified schematic of a rotating run with a single sphere inside of it. At time t0, we have this particle applying a force at point P1, and after a certain rotation, the force will be applied at point P2. The particle remains at the bottom of this geometry, and the geometry is rotating. On Ansys Mechanical side, rather than the geometry be moving, the force will be corrected. Since the geometry does not move, the load will displace, and so that the forces are applied at the point P1 and P2 respectively, just like the original case in Rocky. Today we have a demonstration on how to set up and post-process a coupled DEM FAA wagon loading using Ansys Workbench to do this force exchanging. I will show how to create the Ansys Workbench workflow, how to export the particle loads from Rocky, import pressure loads into Ansys Mechanical, and evaluate the structural integrity of the wagon. So let's take a look at this demo. So we'll start with a simple workflow inside Workbench using three component systems: SpaceClan for the geometry, Rocky for the particle analysis, and a static structural analysis. We can also see that there is a parameter set since we have input and outputs for Rocky and an input parameter for the static structural. So let's start taking a look at the rock setup and see how we can define the loads that will be exported back to static structure. So here we have our previous simulated analysis is a simple loading of particles into this beam, of this wagon beam. We can see that we have a fine and uniform discretization of the geometry, so we have a smooth pressure field back into Ansys Mechanical. So we can change the triangle size directly inside Rocky or bring a pre-generated tessellation from Space Clan, for example. We have created a given an inlet to inject our particles here with a given mass flow. This continuous injection here, we have created a per input parameter, so let's call an M, the target mass that we want to inject, and this can be an input parameter that we can change later on to explore the sensitivity analysis or even optimization. So here we have input and an output, which is the vertical force exerted by those particles. Okay. From the solver side, we run for 5 seconds, and we can define later the external coupling that will always appear when we are already coupling inside Ansys Workbench. Here we can select where this force we want to export, in this case, the only surface we have, and when do we want to export. We can export through all the simulation, at certain time range, at a specific time, or in our case, the last output. So we'll be exporting the pressure field on the surface geometry at the last output of my simulation. With this selected, I can drag the results to be used as part of the setup inside static structure. So I just need to drag and drop from results to setup in static structure, and then I can just refresh this component, and later on, as we will see, these loads will be already available from inside static structure. I will start static structure to finish up the setup of our model. Here we already have not only the surface, but we have 3 support bodies that will be holding up this wagon in place. Okay, as you can see, they were not available in Rocky because we don't want this such interaction. So we can see that the geometry don't need to be exactly the same in Rocky and Ansys Mechanical. Here we have parameterized the thickness of the surface and the mass of it. We already have a mesh in place. And now we can create the boundary conditions of our model. So let's put a simple fixed support at the bottom part of the supports, and then add the imported load. The B4 means that it's bringing the information from the component from Rocky, and it will always be brought as a pressure field. So we can insert a pressure. We need to select where this pressure will be applied, which is the whole surface, the internal surface of the wagon. So let's just hide this for selection, select all the surface and apply to the selection. And I want to define this based on the components of the pressure. Rocky will always export the pressure in 3 components, X, Y, and Z, so I can change the components. And for each component, I will select the load. This 100 is just the last output. We run for 100 outputs inside Rocky. So I can select the 3 components, and I will import the load. After interpolation, Ansys Mechanical will display the actual pressure field collect from Rocky and will be used as the boundary condition for a structure analysis simulation. Let's add just a few analysis as a total deformation and parameterize the maximum one, and also the equivalent stress, and also create a parameter of the maximum stress. We can run our simulation. So we have applied a fixed support and the load imported from Rocky. And we can see here both the total deformation caused by the particle loads. We can see the maximum deformation point at the bottom We can see the formation at the top due to the side contact with the particle, also the equivalent stress acting on the walls of my geometry. This was created as a static analysis, but we could also bring the same analysis as a transient one, bringing multiple loads at different outputs. And if we take a look at the parameter set now, we can see that we have created a few input parameters as the mass inside Rocky, the thickness of the walls in Ansys Mechanical, and exported the vertical force in Rocky, the surface mass, and also the formation and stress from Ansys Mechanical. And with this analysis, we can extend it using design exploration to do sensitivity analysis, direct optimization, or even couple with Ansys OptSlang to build a complete analysis with this created workflow. The results from this simulation can be critical for structural integrity analysis. They will help to determine the best operating conditions, like what's the best material loading conditions, if I want to load from a single point, multiple points at different intervals, and at the same time ensuring that the structure can hold and withstand this bulk load. The simple case could be even extended, as we mentioned, to run a complete optimization or robustness analysis using the same parametric workflow already created. Well, that's the end of our Rocky demonstration about mechanical coupling today. This session completes our Rocky in Action webinar series in 2022. You can access and watch all the past sessions in our technical library by scanning the QR code appearing on the screen. Stay tuned for the upcoming webinars in 2023. Please connect with us through one of our channels, and if you have any questions, please send to us in the chat. Thank you, everyone, and see you next time.